Hi everyone, this tutorial was requested by my patrons. They asked me to create something similar to this colorful infection by Matt Taylor, also known as MT01. It was really fun to figure this out. I don't know if the approach that I explore is similar or the same as he did, but I really enjoyed the colorful result. Thanks to Matt Taylor for his amazing work. Go check his Instagram and give him a follow if you have not done it already. You should. Hope you enjoy this tutorial. Okay, so before we start the tutorial, I want to show you the reference. Okay, so this work, this tutorial was requested based on a work from Matt Taylor, also known as MT01. Okay, amazing work from this artist. And some of you requested this tutorial last year and the first year on Patreon. And finally, I had some time to dedicate and pay a little tribute to this amazing artist. Okay, so we are going to see how to work this, or we are going to see one way to approach this type of work. I hope you enjoyed this one, and let's start by analyzing this video. Okay, amazing art, of course. So I think maybe there might be multiple approaches for this, but I think he has the base geometry, okay, and then he has scatter particles around that you can see; they are invisible. But he has multiple particles scattered on the geometry, okay, on the surface, and then he has an infection system to infect those particles, okay, and if the particles are infected, they will emit other particles, or they will just grow for themselves and get bigger, okay. On this tutorial, we are going to scatter particles on the geometry, create an infected system, really simple system, and then make, if the particles are infected, they will emit other particles, and those particles will create this colorful volume of particles, okay? Don't know if that is the approach of Matt Taylor, okay, but I think it's one of the good approaches for this type of work. Okay, pretty cool work from him. So if you don't follow him already, just give it a follow. Okay, and check all the other works from this amazing artist. I really love this one. I think he has done a tutorial about this one, but check motion design community. I think there is. But this is really cool. At some point you can see the texture. Very cool. So let's check this one more time, and let's start our tutorial. Very cool. So as you can see here, we have particles growing, and I think they are emitting other particles, because you see the particles are getting, we are getting more and more particles during time. Okay. So that's why I think they are scattered, and then if they are infected, they are emitting other particles. And then we are just going to use a simple pop net with the pop grains, so they won't intersect each other, and with clumping, we are going to make them stay together. So let's start our tutorial. Go away, Toggle. I don't want you. Okay. So let's go to our project. So I have a basic geometry here, okay, simple stuff. I did a character on Character Creator 3. If you see my live streams, I'm always using that instead of DAS. So let me show you the beginning. I'm not creating this. You can download this on my Patreon. And if you want to follow along the tutorial without getting the project, you can use a box instead of a character. Okay. So we have a character. I pose it on a Character Creator, okay? I just saw that I had a problem with the hands. You can see that the hands are intersected. And with the new node system from Houdini 18.5, I use just a rig pose to move a little bit the arm. Okay, so I have this pose. Okay, then I use simple boxes. As you can see, I have one here. I position the boxes and a boolean so I can still start cutting out the shape that I want, because I just want the arms. So I created this box, as you can see. I hope you can see that, and start cutting out with the boolean. So then I'll link the other one. Okay, this is just a simple way to get the shape that I want. I just want the arms. Okay, then I use attribute delete just to delete the materials, and the transform to scale it up, okay, by 10. Simple, and position this on the origin, okay? Simple as that. And then I put an out base, a null called out base geo, okay? Then I have here a transform, because I'm going to show you how we can make this system, this infected system, in a deforming or animated model, okay? Because we are going to check how it works in a how do you say, a static object, okay, without animation. And someone on the live stream asked me to try and make the system in a deformed geometry, so we are going to try that too. Okay, but to start, let's go with the static object. Okay, simple stuff as this one. Okay, and I have a really nice ants here, just to have a cool complex model. You can follow along the tutorial with a box, as I mentioned. So now let's start and place our geo and call it particles. Okay, let's dive in. And let's get our starting object, okay, our geometry, and let's go pick our ends. Okay, set. So we have our hands. I'm going to make this invisible, okay, so we can see only here. Let's place a null, and let's call it base geo. Again, if you want to follow these and don't want to download the project and don't want to create this, you can go with the box, okay, or go with anything else, okay? It's up to you. System will work in everything. You might need to change a few parameters, but I will explain along the way, okay? So, as I mentioned, I think the system works with scattering particles, so let's start with that. Scatter, okay? And let's increase a little bit the scatter points to maybe 15,000, okay? So we have a nice dense particles. Pretty cool. Let's leave relax iterations on, because if we don't, the particles can accumulate in some points. So relax will keep the distance even for everything, okay? And now let me think. So we have the scatter points, okay? These will be the particles along the surface, and we need to some seeds. We can call it seeds or starting points of our infection. So to do that, let's place another scatter, okay? And let's call it starting points infected, or other name we can call is seed. For example, in X particles on Cinema 4D, I think it's called seed, the starting points, okay? And on this one, I just want to use like 5. You just want 5 starting points. If you want to place them by hand, you can use an add node, okay? And just create points and do put the points by hand. But I don't want that. I just want to have 5 starting points, so let's go with that. Okay, so we have this here, and now let's start using some vex. Okay, nothing too complex, but we are going to use vex for this one. But before we start writing our own code with point triangle, okay, let's go just put that point triangle and link this like this, okay? And before we start the vex, I want you to understand the logic before we start, because if you understand what we are going to do, it will be very simple to follow along and write your own vex without me, okay? So we have a few particles. Let me decrease this. So we have, let me change the point hard. So we have a few particles, right? And we have an infected one, something like this. Okay. So what we are going to use is that we are going to check a radius, how do you say, a radius around the infected particle. Okay. So we are going to check from a radius, something like this. Oops. Something like this. Okay, we are going to check the particles inside that radius. If the particles are inside that radius, the particles will become infected, as you guessed. So these particles, they are inside the radius of this infected one and will start to be infected. Okay, this is the starting point. We have the 5, as I mentioned, the 5 seeds, right, from this one. We have 5 scatter points along the surface, and we are going to check the starting infected particles. Okay, so let's write these on vex. So we have the starting particle, infected particle. We are going to check a radius. Okay, and if there are particles inside this radius, let's infect them. Okay, this is the basic logic. But in vex, I know this can be a really tricky thing to think about it, but let's try it. In vex, we are going to use the same logic, but reversed, okay? We have the particles, right? We have the particles here, okay? And we have an infected one here. We are going to write vex code that will run on each particle. And it will check the radius. For example, we are going to see this particle, okay? And we are going to check the radius of that particle, okay? If on this radius of this particle, if there is an infected particle, this one will become, as you guessed again, infected. So this one will be infected. Okay, and we will do the same for each particle. So we are going to check again other particle, check the radius, and see if there are infected particles inside that radius, and we'll turn that particle infected. Okay, so let's go here and write that in vex. So to check that if there are particles infected inside our radius, we are going to use, and we will use this on every system of infection. We are going to use the PC find. Okay. If you check the docs, how I am showing you, we have the PC find. Okay. This allows us to find points depending on the radius and max points. Okay. So we have here an example. We don't need to write this down step by step, but let's go and write that just in case. Increase this. Can I increase this? No. Let's go with this. So let's write the same code that we have here. Here. So this will give us an int array. Okay. If you don't know what it is, an int array, I explain a little bit about programming on one of my first PopNet Vex tutorials. It was my second or third one, I think. So this will give us an array of points, okay, array of integers, okay, and we are going to use a PC find. And on this one, as you can see, on the documents, we need the geometry. Okay, this is the input. So we want to check the input of 1. Okay, so as I explained in other tutorials, we have here 0, 1, 2, 3 inputs. And on our case, we want the second one, but because we are working with index, the index always starts with 0. So the first one is 0, the second is 1, third is 2, and the fourth is 3. Okay, if we had these linked here, we need to use the ID 2. Okay, let's go back. Oops, let's go here. And we want to find points on the first input. And we want the position. Okay, let's go with P. Okay, we want to check the position and check for a search radius. Okay. And we want 1. Okay. So again, we have these max points. We are going to use this one. Okay. Pretty cool. So we need to, I put this as a parameter because I want to turn this into a slider. So let's go back and add a channel float. Okay. So let's go float search radius. It's equal to channel float. This will allow us to create a channel on the interface. Okay, so something simple as that. And now if I press here, we will see that we have a search radius. Okay, a slider here with a float. Okay, pretty simple. So now let's keep going, and we have the integer with the PC find. Okay, to find for particles. Okay, along the search radius. Okay, so what we are doing, again, going back, I'm taking a little bit more time to explain you this on the simple PC find because the next one will be a little bit more complex, but we will still use the PC find. Okay, so what we are doing is that we are running this on every single point of this scatter. Okay, and we are saying that go look for a point on this input. Okay, on this second input, go get the position of that, search for a radius, and look for particles. We just need to find one. If there is one particle infected, we are getting this one infected. So now let's go with that. If there is any particle, okay, so when I'm saying land points, okay, this one, we are saying that if there is any number inside of this array, okay, if this array is bigger than 0, bigger than 0. In other words, if we have anything inside of that array, let's infect this particle. So let's add the brackets and then add a parameter, infection equals 1. Okay. So we have these particles, right? We are running this code on each point. Okay, run over points. Okay, go search for any points inside the search radius on this input, on the input with ID 1. Check the position. Okay, use this search radius that we have here, and then look for just one particle. If there is any particle, turn that infected. Okay, so we create a float called infection and name 1. Okay, so if you go see, the geometry spreadsheet. Let's go to points, infection. So as you can see, we have a few of them. Okay, we have some with 1, so it means some of particles are infected and the others are not. If we want to see that here on the viewport, let's do a little trick. So let's use another wrangle. Okay, wrangle. And let's place a point wrangle. Okay, let's go with color infected. And let's color them depending on the infected. So let's go set. Let's use the infection. Okay, and 0, 0. So as you can see by the red dots, okay, those particles are infected. And if we now change the search radius, you can see that we switch the size of our starting infection. Okay, we can go something lower like this. We can even increase this number. Let's go with 35,000. Okay, and we can see the particles infected, they are red. Let's increase a little bit the size of our particles so we can see a little bit better our points. Okay, pretty cool. So now let's use a solver. Okay, and inside this solver we are going to use another vex. Okay, another point wrangle to make them infected. Okay, simple as that. So we are going to use a solver because this is a simulation and we need data from the previous frame. Okay, as you can see here on doping part, we have previous frame. Okay, and let's put a point wrangle again. Point wrangle. And let's go infection system. Okay, so here we are going to create a really simple vex code to make the infection system. Something similar to this one. Okay, so let's go to Photoshop. Okay, so I'm going to try and explain again system. So we have particles, right? Oops, not infected particles. Let's go with normal particles. Okay, something like that. And as we saw before, we have some particles that are infected. Okay, and they are that. So as we did previously, we are going to run a code for each particle. Okay, and we are going to check a radius like this. So we are going to check a radius for that particle here. Okay, and we will see if there is any particle infected there. Okay, and each particle has an infection value, a float, as we remember, and each particle has a different infection float value. Okay, a different infection. So this particle the system is going to be a little different from this one, because this one on the starting points, if there is a particle infected, we are infected. On this one, we want to grow the infection value. Okay, so on this one we are going to see every single particle inside, or a max. We are going to use a channel that we will check for a max search points. Okay, we are going to look for a number of particles inside that search radius. We are going to get the infection, right? We are going to get, why can't I write? Okay, so we are going to get the infection. We are going to get the infection value for each single particle inside that search radius, and we are going to use the average of that values to infect our current one. Okay, so what I mean is this. Imagine that we have a particle, right? We have this particle. Okay, and we have other particles infected. We have other 4 particles infected. And this one is already infected. Okay, 1, 1. But this one is just 1.1, and this one will be 0.2 infected. Okay, this is the infection value. So this one will not become 1 in just one code. Okay, we are going to do the average of the infection of the particles around me. So we are going to get the infection of that one, add the other one, add the other one, and add the last one. Okay, so we are searching for 4 particles, and we have this number that is 2. Let me use another 2 by, oops, sorry, 2.03. Okay, that is the sum of these infection values. Sorry. And we are going to do the average. Let's divide that by 4, and that is equals to, let me go to Google and make the math. And that is equal to 0.5075. Okay, so that means that now this particle will be a little bit infected. Okay, not that much, with a value of 0.075. Okay, on the next frame, this infected particle will again look for other particles, another 4. Imagine it's the same. So we will add this current average to the already infected value of that particle. So the next frame, this will be something like this. Okay. This may look a little bit complex, but you will see with VEX that is really, really simple to do. Okay, so to summarize everything, we have the particles. We are going to search for a radius. We are going to look for particles inside that radius. Check the infection value of each particle. Let's sum that or add every single infection value for each particle. Let's do the average, okay? And let's add that value to the current infection value of my particle, okay? So let's do that in Vex. So let's go to our solver. Let's go call it solver infection. Okay, so we know what we are doing. And here on the infection, let's write our code. Again, we are going to use the PC find. Okay. Again, we are going to use the PC find to search particles inside our radius. So right now, let's copy paste this one. Okay. And let's paste it here. Let's press Alt E so we can have this bigger. Okay. And we have our system. Okay. So let's start changing the code as we want. So let's go with close points, okay, because I know that I want some. Our file name, as you remember, we need an ID here, and we are just using the first input. So let's go with 0. Okay. And we want the position, simple as that. And we want a max distance. We call here search radius. Let's call it search radius to keep everything more like consistent code. Okay, and max points search. Okay, because we can limit the number of points that we are searching inside the radius. Okay, so imagine we have 5, but we have 10 points inside the search radius. We are going to ignore the 6, 7, 8, 9, and 10th point. Okay, we are just working with the 5. Okay, so let's by now let's create a channel float and a channel integer. So let's go with search radius. So this is a float, call it search radius. And max points, it must be an integer. So let's go max points. Oops, max, not more. Max points. And this will be a channel integer. Be careful with this one. And let's go max points. And everything like this. Okay, so we are going to get the close points inside, okay, this search radius and with the limit of these max points. Okay, and as I said, we are going to, let me go to Photoshop. We are going to get the sum of our infection values. Okay, so let's go here and let's go with float infection. Oops, float infection sum. And we are going to start with 0. Okay, so for each point inside the close points, we had an S here. Okay, so now for each, we are going to go and check every single particle that we could find with this specifier. Okay, so if we find any particle, we are going to add that to our close points. So now on the for each, we are going to run every single particle. Okay, so let's go here. And on this example, we are going to check, we are getting the position, but in our case, we want the infection value, right? We want the infection value to add to each single previous one. So let's go here. We know we want a float. Let's go with infection value, okay? And we want to use the point function. This point function allow us to get a value from a parameter of a particle, of a point. Point and particle are the same here. So our we need a few parameters. So the first one is our geometry, our input. It's 0 because it's the first one, right? And we need to get the infection parameter, okay? And from our point num, okay? This point num, remember, it's the integer that we are going to use here, okay? So because we are running for each, okay, this is a loop, and we are going to check every single particle inside these close points, okay? So now that we have our infection value, we need to add this infection value to the infection sum, okay? So let's go here and add that infection value. Okay, go like this. So by now we did this. Okay, we search for particles. Okay, we did this. We search for particles. Let me change the color. Something. Let me Control Z. So with this code, we search for particles on a radius and check the infection value of each single one of them. Okay, and then we create the sum, or adding every single infection value of those particles that we could find inside the search radius. Okay, and I know I have an error here. We need add p because it is a parameter. Okay, no errors now. So we did that. So now we need to do the average, right? So we need to divide this for the number of particles that we added. So one way to check that is to use the len of close points. In other words, as we did previously, check how many points we have inside the close points. Okay. So to do the average, let's go average infection. Okay, we can understand that. Average infection will be our infection sum, right? Divided by the number of infection values that we added. In other words, how many points we have inside our close points. Simple as that, okay? And now we did the average. Now we need to add that average to the current value, infected value that we have on our particle, right? So now infection will be, or we will add this average infection to our current infection value. Okay, press apply, and this. Okay, let's go accept, and everything should work together now. Okay, we can see here, but remember outside we have this color infected. Okay, and let's see if this works. We just forgot to do one thing. Let's press here because we have channel floats, and let's go with search radius of 0.1, and let's go for 5 or 10 particles of max points. Let's go up, and let's see if this works. As you can see now, this is working. Pretty cool. Now we have some problems here because, and we need to optimize this code, is that we are infected particles that are already infected. Remember that some particles are already maxed out. They are all infected already with 1. So we don't need to keep running this code on that infected particles, and that's why it was doing that little weird ring effect. So we need to check if the particle is already infected. Okay, so run this code only on particles that are not infected. So let's go with this and close that bracket. Let's go here. So we are saying that run this code only on particles that are not maxed out, not infected already. Okay, they can be infected again. They can be with the values of 0.2, but if they are maxed out, if the value is 1, don't run this code because they are already infected. Okay, let's press apply, go up, and if everything is correctly, you can see that every single thing gets infected. Pretty simple, right? So now let's add some noise to our growth effect, because as you can see, our infection is pretty uniformly, right? Because we are using a search radius, and search radius is an ellipse, okay, around the particle, and everything is really uniform. So we are going to add a noise to change this linear growth, okay? We don't need to do that, but it's a really nice tweak to add to this system. So let's go with VOPs. You know I love VOPs, so go with point VOPs. And let's go add turbulence, okay? Let's go here. Let's put a turbulence, as I mentioned. 1D noise, it's okay. And let's turn this to a ramp. Let's go with this ramp to a spline ramp. And to visualize this noise, let's link this to a channel float, to a channel color, so we can see the colors of our ramp. So here. And let's bind export. And we want to export that value into a new parameter. Let's call it infection multiplier. Okay. And this will be a float. Okay, pretty cool. Now particles will have an infection multiplier that will be guided by these turbulence. Okay. Let's promote this parameter so we can adjust this outside. Okay, pretty cool. So now we have a few parameters. If the particles are black, they will not be infected. Okay, so this gray scale, okay, these gray values will limit the growth or the infection values. If they are white, they will keep running like it is. Okay, simple as that. But if they are gray, we are going to multiply. Let me go here. Imagine this value. Okay, so the average was 0.5. We are going to multiply by that infection multiplier. Okay, if they are white, it will add that value. Okay, but imagine the value is the infection multiplier is gray, half gray. Okay, the minimal point. It will be just adding 0.25. That means that the growth infection on the black spots will be slower than the white spots. Okay, so let's add some noise to that infection multiplier. So let's go maybe increase this. Let's add something like that. And we don't want black spots because that will mean that we won't have growth infection there. Okay, but let's see if this works. Let's go something like this. This will be nice to test it. So, oops, let's go up. So right now, let me check. The particles will have an infection multiplier. Okay. Let's go here. Let's copy paste the name. So we won't write it wrongly. And we just need to multiply by the infection multiplier. Simple as that. We don't need to do any little tricks. So we are going to use that infection multiplier, okay, this parameter, to affect our growth. So let's see how it goes. And as you can see, we are not growing on the black spots. Okay, because the multiplier is 0. So anything that is multiplied by 0 is 0. Right? So we can control the growth effect like that. So in our case, I don't want to be completely black. Let's go something more grayish. Okay, something like that. Decrease this. Something like that. That looks cool, right? So now let's go check our growth and you will see a noise here on the parameter. Cool, right? Now it's not growing with that linear flow. So now if you think that the growth is right starting with a bigger ring, now you can adjust the way you want. So now you have these channel floats. You can max this to 5. The search radius, let's go with 0.25, but we just want to use 5 points. Okay, let's see how it goes. Oh, it is a little bit slower. Okay, if you want, let's go here. Let's go with 0.1 and let's go with 50 points. You will see that this will be bigger. Okay, we need to reset. Okay, I was like, what? It should be faster. Okay, sometimes you need to go to solver and press reset and force to reset. As you can see that now we increase the max points, so we are checking more points on our search radius, so the growth will go bigger. Okay, so let's go back to 5, and the growth now should be really slow. Okay, cool. Let me be sure that we reset everything. Okay, so now we have our infection system. The cool thing about this system is that now, if you want, if you are not happy with the starting points, you can always come here, change the global seed, and as you can see, our starting points are changing. Okay, and as I mentioned before, you can come here, go add, and add your own point and link this here. Okay, simple as that. So now we have these starting points. Pretty cool. So now let's go back to our reference, remember? And we have our infection system. Now I want to emit particles and make them grow and stay together. Okay. So for that, we are going to use a simple popnet. So let's go now with a group expression. And what I want to do is that we want to use a popnet and emit particles if the particles are infected. Okay, so imagine these particles are infected, emit other particles on these ones. Okay, so in other words, I want to delete the black particles, the particles that are not infected. So we will have only the infected ones. So this on this group infected, let's call it infected group. Okay, and the expression is simple as if the infection equals to 1. Okay. Oops. And I want this to run on points. Okay, and now let's use a blast and delete everything. Okay. So if the particles are infected, use delete the other ones. But as I can see, the number 1 is way too big. So let's go if the particles are above 7, 0.7. Okay, now I have particles. Okay, so now as you can see, I am deleting the particles that are not infected. So if they are above 0.7 on the values, okay, we are keeping them. Okay, so we have a really nice system. So now let me go back to 3 here. Okay, so now let's place a null. And let's go with out infected particles. Okay, now as I mentioned, let's use a simple popnet. So this way is really simple. That's why I created this simple system with vex and particles. So now on popnet will be really simple. So now we just want to scatter on all points. Okay, simple as that, and use a grains. Okay, and be sure to uncheck assume uniform radius. Okay, and clamping we want 1 and we want really big. So the maximum is that. Let's off that. Okay, constraint is everything. All right, so for the pop grains, and we uncheck the assume uniform. I covered these on previous tutorials, so I'm going to cover these really quickly. So we need p-scale to work with our particles, and as we saw on the reference, the p-scale is increasing. So let's put a simple wrangle here. Let's reset the p-scale. P-scale equals to 0. Okay, and we need to increase the p-scale during the popnet. So let's go place a wrangle. Okay. And let's increase the p-scale by 0.001, for example. Okay. And right now the p-scale will increase 0.01 in each frame, right? But we need to limit the p-scale. Otherwise the p-scale will get really high values, okay? And we don't want that. So we need to clamp it. So the p-scale, we need to clamp the p-scale. The value is p-scale, and we need to clamp between 0. This is the minimum volume, and the maximum, let's go with 0.02. Okay. We will tweak this later, I think. Okay. So right now, if I check this, let's go, and we can see that our growth is increasing, and because we have the clamping turned on, the particles are trying to stay together. Let's place a sphere so we can see this a little bit better. Let's go with copy 2 points. Be careful with this one because this can get really heavy because we have a lot of points. So depending on your computer, be careful with this one. Okay, so as you can see, we have the thing that we need. Okay, so one thing that I can see is that we have a lot of flowing or flying particles, right? Because they are intersected and the pop grains are really forcing them out. Okay, and if we don't reset the velocity, I learned this with Entagma on the packed surface torus with particles. If we don't reset the velocity that pop grains is adding to the particles, they will keep flying away. So one little trick that I learned with Entagma is to reset the velocity before the pop grains, okay, on the start of our pop source. And if everything works together, they will stay together, the particles. We don't have flying particles because the pop grains is forcing them out, but on the next frame we are canceling that velocity that pop grains was adding. So we don't, pop grains is avoiding the intersection, but with that v equals velocity equals to 0, we are turning off that flying velocity, okay, the constant that pop grain was adding. So we have something like that. Pretty cool. Okay, so now if I turn on our ends, you can see on the start that we have particles going inside our ends, and that's not cool, right? So let's go to frame 1. Let's go to our base geo and let's add a static object or deforming object. I'm going with deforming object because I want to show you how to deform this afterwards. Let's check that. So it created this for us, okay? And inside our .NET, press L, and now we have our base geometry, okay? Let's check the volume, display geometry, and check the volume. So let's decrease this a little bit. Okay, that looks cool. Maybe even lower. Okay, something like that. That is cool. So let's go here. And now, if everything goes correctly, our points will not go inside our hands. Let's go here. Let's go, let it process until frame 60. See how it goes. Okay, almost there. So as you can see now with the hands and the collision, it takes a little bit of more time to process everything. But as you can see now, we don't have particles inside our hands. Okay. And we have that. Now copy 2 points. As you can see, we don't have particles inside our hands. So the infected is going outside. Okay, so as you can see, we don't have particles inside the hands because we have that collision. That means, let me try that live, that if we invert the sign of this base geometry, okay, this static object, let's see how it works. I'm going to try this live. So that means if I turn that invert sign, we have the growing effect inside the hands. Let's see how it works. And let's see if it works. I think so, because we have the particles on the surface. So the collision, if it works for outside, it is working for inside. Okay, pretty damn cool. So now we can have an infected system inside the hands too. Okay, pretty cool. Let's go back because our reference was growing outside. Okay, and now let's add some colors. Okay, so to add colors, we want the particles to stay with the same colors, but we want to have different. Okay, we want something like this. okay, colorful infection. So let's go here and let's put a point swap. Okay, let's go to our point swap. Let's add a turbulence. Let's link this and let's leave to 1D. Let's put a ramp. Link this here and the ramp go to the channel color. Okay, now let's right click, vex, create input parameters, and let's go up. So let's go here and let's go to a cool. Okay, so we have the particles here. I hope you can see. Let's increase them a little bit so you can see the colors. Okay, cool. Let's increase maybe this to 4. Okay, let's go with another one. Increase this maybe like that. Okay, and let's add some colors. Maybe, I don't know, blue. Let's go to something like greenish. Let's go to a yellow, orange, a little bit of dark red. Okay, and let's go with a purple, dark purple, something like that. Maybe sparse is not cool. With simplex, alligator. Alligator is cool. Can I switch? Maybe something like that. Okay, cool. And now let's, maybe this is too big. Something like that. Okay, that looks cool. And add a little bit more purple. Add something like that. Okay, I think that is cool. Now, as you can see, the turbulence is always the same. So let's animate this. Times maybe 0.5. Now we have more. Go back to 5. Something like that. I think that looks cool. So now that our current base particles have colors, okay, color particles, our emission will have colors too, because when we emit colors, when we emit particles based on other particles, if the base particles are already colored or have a parameter named color, the new ones will become with particles, with colors. Okay, so let's go back and okay, so everything is all right. And let's emit particles. Let's go to frame 60. Again, let it process everything and let's see how it looks. Okay, while this is processing the system and simulating everything, to work this or make this work for a deforming object, we can use the same system as we did on our dancing. Okay, so on this tutorial, oops, let me turn off. On this tutorial, we explore here how to stick particles to a deforming object, right? With this little system. So it is the same, okay? So this way we can stick particles to our moving object using the primitives, UVs, and everything else. So I'm going to show you how it works. So before that, let's check how it looks. Pretty cool. So we have now our colorful particles. Okay, cool. So let's go back and let's see how we can stick these particles. Okay, So as you can see, we use a time shift to stop the animation, and then use scatter, and then attribute interpolate. Okay, simple as that. So I'm going back to our base geometry, and I did a simple animation here on the hand. Okay, so as you can see, the hand, oops, let me turn off the particle so we can see what I did here with the rig pose. So as you can see, we have that hand there. Okay, if we are animating, and I'm showing you this because I had this problem. If we use a boolean after that and a transform, this will not work because we are animating, okay, we are deforming and then adding a boolean. So we are changing the UVs, as you can see here, the polygons, as you can see. Check this out. We are changing the topology each frame. So this little trick that I'm showing you, this will not work. This will work only if the topology is always the same for each particle. So in our case, on this case, we are going to use the geometry without the boolean. Okay, we are going to use this one. So on this one, the topology is always the same, and we have the deformation. Okay, cool. So now on our particles, our object merge will be the other one, will be our out base no boolean. Okay, so we have this one. Okay, this geometry and our scattering. Now we are scattering on everything, of course. Okay, but now as you can see, the particles are changing, but they are following the animation. Okay, cool. Now we need to stick them. So in order to do that, we need to time shift and attribute interpolate. So what we need to do is place a time shift. Okay, Control Shift click to delete the keyframe. So we are shifting our animation, stay always on the same frame. Scatter the particles, okay, and we are going to work with this. Okay, we have these particles. On the scatter, we need to do this prim number attribute and prim UVW attribute. We need to check these two. Okay, because the attribute interpolate will use that to interpolate the particles. So we have the solver and everything else. Let's go here and turn this on too. Okay, so now our starting points will be on every particle. Okay, on the full body. Okay, so now we have the solver. Let's reset this and check the color infected. Okay, and as you can see, now the infection is growing along all the body. Let's increase this to maybe 50 and reset this. Okay, now we have a bunch. Let's increase this a little bit. Okay, cool. Now we have a cool infection. Okay, so now let's interpolate. Remember, interpolate. And interpolate these new particles, okay, with the base geometry. And now, as you can see, our infection is working with a moving object. And everything else will be the same, right? Now, we delete the particles, okay? We are just staying with the infected ones. We reset the p-scale. We add some colors. And we will emit our popnet, our particles, okay? So now we have something like that. And we have an infection system, colorful infection system on a moving object. In case that your moving object is colliding with the previous particles, go here and check this reset of velocity, or multiply this. Oops. Or multiply this by 0.25, 0.2 or 0.1. In case that your collision, your moving object surface is colliding with the previous particles, okay, and you need them to move with the collision, okay, just delete this or multiply by a 0 point something, okay. So by now let's go with this, simple, and go here and check this one, because I don't need. And let me see if everything is correctly. Let's decrease this to 0.25, and here I just want 5. Okay. And let me see if this works. So this is not. Okay. Let me see what am I doing wrong. So the base geo. Okay. So this is telling me that. Oh, okay. Sorry. Not base geo. Okay. Let me be sure that we are working with everything correctly. So now our merge. Ah, okay. I need, oops. I need to turn off this one. So my base geo was being animated. Okay, now everything is correctly. Okay, we have our static object. Okay, let's reset the simulation. Check if everything is all right. Let me see if they grow. Okay, cool. Now our blast. Okay, as you can see. Very cool. And then everything will work as we did previously. I hope I didn't lose you in the explanation of the infection system. Sometimes I feel that I try to explain everything in detail that makes things worse. So let me know in the comments if you enjoyed the tutorial and understand the system. Hope you have fun exploring this workflow, and don't forget to share your work with me. Thank you so much, hope you enjoyed this little system, and see you on the next one. Have a nice day and stay safe.